All right, so this is page 23 notes. And we're going to talk about the Y-intercept. Please make sure you copy the slope and the X-intercept. Make sure your notes look just like my notes. All right, so I'm going to divide this into 4 sections so that we can have the titles here, talk about the Y-intercepts, talk about the slope, and then the X-intercept. All right. Okay, so now we have the Y-intercept. We have the slope and the X-intercept. So I'm going to tell you what they are, and then we're going to talk about how do you get them from a table, an equation, and a graph. So the Y-intercept is the beginning point. It's the initial value. It is the point on Y-axis. So we have the Y-axis. It goes like this. That's the number line. Okay. Here's the Y, and wherever the graph crosses this Y-axis line, wherever the graph crosses that line, that's your Y-intercept. What I like to draw, because it's the beginning point, B for beginning. The symbol for this one is the letter B. Okay, like that's like how we write it in a sentence. That's how we notate it. Like if you didn't want to write out the whole word, you could write B, and because it's the beginning point, I like to draw a banana for this one so we know it's the Y-intercept, okay, when we have the graph. I draw it there so it's easy for me to read or understand, and it's just something easy to remember. The slope is the rate of change. And so what that means is that 2 things are changing. That means, and the notation for slope is M. It's the movement of the graph. It's how things are movement, whether it goes up or down, rise over run. And so what it's changing by, you're figuring out how the you're doing how the Y's are changing over the change of X. So it's 2 different quantities, 2 different things that we're talking about. That's why it's a rate of change. We're comparing how the Y's are changing over the X value. So whatever the dependent over the independent. These are 2 different quantities, whether we're talking about how the amount of money they have is changing over the number of days, or whether the number of gallons in a tank over the number of days. But these are 2 different quantities that we're comparing. And we're seeing how this together, that's the rate. And it's movement because once you see the graph is going to be like this. This is when we draw. So this is when we draw the stairs. Let me see, I'm going to do this. So we're seeing what's the change of Y, whether if it's going up or down, over how many it's going to the right. So this is when we draw the stairs. So this right here, we draw a banana for that one. That's just an easy way to remember. It's not like a math thing. It's just a way. It's like any other thing. And for this one, we draw stairs. Sometimes it's easy to give a mathematical concept an easy, funny way to remember it so that you remember it better. The X-intercept, there's no notation for the X-intercept, but the X-intercept is just the point on the X-axis. Okay, and what we draw for this one is a heart, because I like to say your X used to have your heart. So there's the Y-axis, right? There's where it touches the Y-axis. That's your Y-intercept. Where the graph touches the X-intercept, that is the X-intercept. Okay, so the banana goes on the Y-axis. The stairs are the movement, and then the X-intercept is the heart, where it touches the X-axis. Your X used to have your heart. These are the stairs for slope, and then the banana for the beginning point. B for banana, B for beginning, B for the B. Okay, so these are the three things we're going to talk about all semester long. Now, we're going to write, how do we get the Y-intercept, the slope, the X-intercept from a table, an equation, and a graph? So let's do the first one, the table. So for the Y-intercept, to get the Y-intercept from a table, what you're going to look for is where X equals 0. Wherever X equals 0, that's your Y-intercept. That's your banana. So let's do an example. X, Y values. So it's not the first value. It's not the first coordinate. You're just going to look for the X side, and you're going to look for 0. Once you find 0, that is your Y-intercept. Okay, so I'm going to put a little banana on the left-hand side because the 0 is on the left, and that is my Y-intercept. It would be the 6. So let's do an example. Let's make that 5 actually. So what would be the Y-intercept in this problem, in this table? You would look for the 0. Found the 0. There's my banana. My Y-intercept would be 10. It wouldn't be 6 because you're looking for where X is equal to 0, not the Y is equal to 0, the X. So this would be your Y-intercept, where X is equal to 0. That's what this is saying. Here, the X value is 0, so this would be your Y-intercept. Let's do another one. What would be your Y-intercept for this one? You look where X is 0, right there. That would be your beginning point. Your banana would be at 10. Y-intercept would be at 10. So that is for the y-intercept. How do you feel? Does that make sense? All right. Now let's do the slope. We already said the slope is the change of y over the change of x. What it means to do the change of y over the change of x is you're finding the differences between the y values and the x values. So to find differences, to see how it's changing, what we do is we have an equation. We have a formula. So you pick 2 points. Write them. Write and label x1, y1, x2, y2. That's what you label the points. x1, y1, x2, y2. After you do that, you use the formula. This formula doesn't change, and the formula is not the same way we label the points, because in every point, when you write it, it's always x and then y. This is the first point, x1, y1. This is the x2, y2. This is x3, y3. You just put 1 for the first point, 2 for the second point. If you had a third point, you'd put 3. But you only need 2 points, and you can pick any 2 points from the table. So what I'm going to do right now is I'm going to pick 2 points. I'm going to write them down. I'm going to label x1, y1, x2, y2. Subtract the points, just like I have on here. The y always goes on top. The x is always the denominator. Okay, so I'm going to pick 2 points. It doesn't matter which 2 I pick. So I'm going to pick 2 points. I'm going to write them down. I'm going to pick these 2 points. Doesn't matter which one you pick, but I'm going to pick these 2. And we're going to do it twice so you can see that there's no difference. All right, so I'm going to write them down. 0, 6, 2, 2. And then I have to label like how I have it here, x1, y1, x2, y2. I have to do that. So if it helps you, I'm going to do it this way, just so it can help anybody. But you first do x. When you label, you have to label correctly x, then y, x, then y, and I have to label this correctly, x1, y1, x2, y2. So this is the first point, so I put a 1. First point, so I put a 1. This is the second point, so I put a 2. This is the second point, so I put a 2. Oh my goodness gracious. My nose is so itchy. Hello, you're kind of early and I'm recording. Okay. So I'm going to do coordinates. So it's y2. Y2, it says right here, is 2. So I put 2 minus, have to do minus because it tells me minus, y1. Y1 is 6. So once you label, you know exactly how to use this formula. x2 is 2 minus x1, which is 0. Now, I can subtract in my head or I can subtract in the calculator. So 2 minus 6 is -4. 2 minus 0 is 2. And now I'm going to reduce this. -4 divided by 2 is -2. And I ran out of space. Which, if I had to write this as a fraction, it would be -2 over 1. If I just want to simplify, it's -2. But if I want to graph it, it's going to help me if I write -2 over 1. Why is it this? Because this is saying -2. If you divide -2 by 1, you get -2. I can't put another number here, and I can't put 0 because you can't divide by 0. It would be saying like you spend $2 every day. You say every day. In English, we don't usually say every one day. We just say $2 every day. And that's the same thing as saying spending $2 every one day. You just typically don't hear people say that. All right, now I'm going to show you what if I had, I'm going to show you another thing. I'm going to show you on the graphing calculator, and I'll link this. This is Desmos. This one is. So you can type it in here, or just on your, I think your phone will do negatives. Most phones do. 2, the numerator 2 minus 6, enter, I got -4, and then 2 minus 0. I don't think you need to put this in the calculator, but I'm going to show you 2 minus 2 is 0. So then you can type in the calculator -4 over 2 to see if it simplifies. See, it even writes it as a fraction for you, and it equals to -2. Okay? And so I could show you, look, -2 over 1 is the same thing as saying -2. All right, so let's move this. Okay, so I'm going to show you what if I had picked a different set of points. What if I had picked that? So first thing, I write them down, -2, 0. Oh no, that was 10. If you write them down wrong, then you're going to get the slope for a different set of points. So again, it's always x1, then y1. X always goes first, and then the y. X2, y2. Okay, so let's put this in our formula. y2 is 6, minus y1 is 10, x2 is 0, minus x1 is -2. So that means I write minus a -2. This minus is minus. Whatever's here, if it's positive, like it was the first time around, so then or it's actually negative. So like this one, -6, it's +6. So it's just a minus a +6. Here, though, it's minus a -2. So if you're not so great at doing this in your head, you can put it in the calculator. Okay, watch. 6 minus 10. And even if you're thinking, okay, that is easy, you want to make sure that you do it correctly. That's something that's really important about math. Even if you try and you're really nice and you work hard, it's really important that we get the correct answer. So 0 minus a -2 minus a -2 is a +2, which is the same thing I got here. So no matter which set of points you pick, you're going to get the same slope because the stairs is always the same. You're supposed to create the same set of steps. You create the same movement every time. That's what makes this linear, is that it has a constant rate of change. That means every time is changing by the same amount. If it wasn't changing by the same amount, it would be a different type of function. Changing, okay, by the same amount each time. That's what linear is. Every time you're doing -2, -2, -2, or -3, changing every 2 days. Whatever it is, that's what makes it linear. And that's why you have lines. That's why it's called linear, because we have lines. Every time it's changing by the same amount. Okay, if I simplify that, I'm going to get the same slope. So this is what we're going to work on today. Next part, let's talk about the x-intercept from a table. What you're going to look for is where x equals 0. Okay, so let's do that one. I'm sorry, did I say x? Oh my god, I meant y. It's the opposite. It is the opposite. So when we're doing the y-intercept, x equals 0. When we're doing the x-intercept, y is equal to 0. I don't know what to do with my allergies. I've already taken like so much medicine. But okay, whatever. Do I have enough space? So in this one, what would be the y-intercept on this one? The y-intercept. For the y-intercept, you look for x equals 0. So that would be the y-intercept. But we're looking for the x-intercept where y is equal to 0. It's the opposite. If you're looking for the x-intercept, it's where y is equal to 0. Here, y is equal to 0. So I put a heart on the right side because we're looking for the 0 on the right side. Okay, so my x-intercept would be 3. My y-intercept, banana, like the minions say, would be 3. Because here the x is equal to 0, like this one. That's the banana, okay? Heart is where the y is equal to 0. Let me have you do some examples. What about this one? What would be the x-intercept? X-intercept is where y is equal to 0. So I look on this side. What is it? The x-intercept should be 6 because the y is equal to 0 at 6. Okay, what about this one? What about this one? Which one's the x-intercept where y is equal to 0? Exactly, 5. All right, so let's talk about the equation. So the equation, when we do these, we're going to assume that it's written in y equals mx plus b form. Okay, that's what we're going to talk about right now, and then we'll work on it also this upcoming week. So the y-intercept is the b. Notice that this one has a letter y, this one has a letter x. The b is not going to have any coefficient. It's not going to have the x or the y. B stands for a number. It's just going to be the number without x or y. So let's write that down. So what we do is when it's in the equation, I always like to underline them, okay? And I like to squiggly the one that has the x. You remember that? Okay. It's the one that you underline. This is the number without x or y. So let's do an example. If it says y equals 2x plus 3. So I look at it. What's the number that doesn't have any letters? Any x, and it doesn't have an x, it doesn't have a y. So this is a y. This has an x. So I'm going to squiggly it. This one right here, the 3, doesn't have x and it doesn't have y. So my b, my beginning point, my y-intercept is 3. Because it's the one, wouldn't be this one, it wouldn't be this one, it's this one. If you don't underline a number, let's see an example. Let's just say it says 4x. Okay, so that's the letter y. This has a squiggly. Do I underline anything? Do I have a number there that doesn't have x and it doesn't have y? I don't. So my beginning point is just 0. I don't have something. We don't write plus 0 because in math we want to reduce it and make everything simplified. But your beginning point would be 0. Let's do an example. Okay, what about that one? What would be the y-intercept in this one? This one has a squiggly. This one does not, so I underline. So what would be my beginning point? The one that I underline, the one that doesn't have x, it doesn't have y. My beginning point would be -5. Okay, What about this one? So we squiggly. That one has an X. I don't have a number there. My beginning would be 0. My y-intercept would be 0. All right, let's talk about the X, the slope. The slope is the one that we squiggly, okay? And so that is just the number. This is just the coefficient of X. So it's however many X's there are. It'll tell you. Okay? So in this example, my slope is the one I squiggly. Coefficient means the number in front of that letter. Okay? It's the number in front of that letter. Tells you how many of that letter there are. So instead of writing literally, instead of writing, for example, if I have 2 X's, which I do here, instead of writing this, I just write the number to represent how many there are. If I had 4 of them, I don't want to write them all out. I would just write 4x to know that there's 4 of them. So here the coefficient would be 4, the coefficient would be 2. So let's do an example. What about this one? What would be the slope in this problem? That's the one with X. I squiggly this one. The coefficient is 4. So how about if I do so a squiggly, that's the one with the X. Let's underline. That's the number without X. So for this problem, my slope, coefficient of X, would be -3. The negative is super duper duper important. I could also rewrite that, Ahad, as -3/1. Now, this one trips up a lot of students. Don't be like them. What about this one? What's the slope here? What do you think it is? Squiggly, underline. So I squiggly the X, but I don't literally see a number in front of the X, but we don't always have to write, like we don't write 0, we don't write +0, but it's how many X's there are. So in this problem, how many X's do you see? Right there. You see 1 X. I don't have to write the coefficient of 1 there because why? I just have an X. I write the number instead of having to write them all out. That replaces that. But if I just have an X, I don't have to write 1X. I just write X. So I see 1X there. If I didn't have any X's, then you wouldn't see any X's. That would be the coefficient of 0 because you wouldn't see anything at all. So here your slope is 1 or 1/1. Anytime you don't have a denominator, that denominator is 1. We don't have to write the 1. So let's do another one. What if you have this? Squiggly, underline. Squiggly if the one with the X, underline the one without X or Y. So here I don't see an X, but I see a number that does not have X or Y, so I underline that one. That would mean my beginning is 5, the one I underline. What about my slope? How many X's do you see? You don't see any, so your slope is 0. Okay. Now, for the X-intercept, these you just look at. For the X-intercept, you have to solve, which will be another day. All right, last one, the graph. Now, for the graph, these you just look at. This one has some steps to do. So this one right here is a point on the y-axis. You just look. Okay. Wherever it crosses the y-axis, crosses it right there. It crosses it at 7. That's your y-intercept. Wherever it crosses. Okay. Let's say we have another line. Okay. If it crosses here at -2, well, honey, that's your y-intercept. Wherever it crosses this y-axis, that's it. Your slope, though, is a little bit different. It's going to be like the table. You pick 2 points, and you're finding the change. Here, it's just looking at it, finding it, that's it. Here, though, you have to pick 2 points. You need to draw the stairs. And then you count. Because that's how you're finding the differences. You count. So the slope is the rise. How much is changing in this direction over the run? How much is changing in this direction? Okay, this is the rise. How much is changing this way over the run? This direction. So the rise, if it's positive, it's how many it goes up. If it's negative, it's how many it goes down. Over to the right. If we're going in forward, we always go to the right. If we're going backwards, we go left, and we have to do everything backwards. But because the numbers are going increasing, 0, 1, 2, 3, 4, 5, we're going in this direction to the right. Just like when you read in English, you read left to right. Okay, if you're going backwards, then there's a new set of steps. The X-intercept, it's one of those that you just look at, and it's just wherever it crosses the x-axis. So I'm going to draw this again. Here's the x-axis, point on x-axis. The y-axis goes like this. The x-axis goes like this. Okay, so I have a graph there. Crosses right here. That's my x-intercept. If I have a different graph, oh no, oh no, oh no. And it goes like this. Okay, I just messed it up. Pretend I didn't draw this. Oh no. Draw one there, because they kind of run into each other. That's where the x-intercept would be. Okay, wherever it crosses this graph, this line. Okay, hearts, x-axis goes this way. On this one, the hearts go here. The bananas go on the y. Make sure you take notes. There'll be another video, and we're going to do lots of practice about this.